All right, so today we get to do investigation 2-3, and the purpose of this lesson is to kind of start to get to introduce you to what the looking for Pythagoras, the Pythagorean theorem is all about. So our focus today is how can you find the distance between any 2 points on a grid. So at times we'll have a straight line, right? So we know that the distance from like one unit to the next unit, that's 1, right? So if we were to ask the distance to that point, we could use like our rectangle or our area formula, right, to basically say, well, if these sides are all 1, so the length of that segment was 1, okay? But what happens when we have a diagonal like we have here in the example? So it says you can use a square to find the length of a segment connecting dots on a grid. So as you see the one over here, you can see the square is kind of tilted. It's not a perfect square. So to find the length of the segment on the left, it says draw a square. Well, there's an easier way to do this, okay? And we are going to show you, all right? So instead of making a square, to find this length, we can make something called a right triangle. So I got this line right here. I'm going to draw a line to connect and a line across, and now you see my right triangle, right? And I have a side length over here of 1 and a side length over here of 2, my 2 legs, okay? So I can find the missing length by doing a little task. I can take the square of the 2 legs, okay? So 1 squared plus 2 squared, okay? And I know that 1 squared is 1 and 2 squared is 4. So that comes out to 5, right? So at 5, that would be the area, right? Okay. Sorry about that. Got a little distracted. So if I'm trying to find the side length, I'm going to take this answer that I got and I am going to square root it. Okay. Because again, it's the sum of the squares of the 2 sides. So this 5 is this side squared. So again, if I need to find the square, I square root 5. So the square root of 5 is your answer, or 2.2. Okay. So that side length, I'll draw it in green, right here, is this. Okay. So it says, how can you find the exact length of a line segment by connecting any 2 dots on the paper? And that's the little trick we just showed you. Okay. So again, seeing this area here, you can see we attacked this part of the triangle, right? Same thing to your left. Okay, so again, that was 1, that was 2. And no matter where I go, what triangle I were to make, notice that they're all the same, right? So again, when I come up with an answer, okay, I'm basically coming up with the square, okay? So I'm going to write this a little bit easier for you too. So think about it this way. If I had 1 squared plus 2 squared equals, and we'll call this diagonal just a side, so the third side. We've always talked about it as the hypotenuse, but you get the idea. So again, when I get that 1 plus 4 equals that, okay? So when I get down to here, just like we did the square roots the other day, right? Some number squared is 5, okay? Well, we square rooted both sides because the square root of s squared is just s. Because to get s squared from s, we take s times itself, right? Well, the square root of 5 can either be written as the square root of 5, you can leave it like that, or if you want to make an approximate value, you can round it to the nearest tenth, and it's about 2.2. We spent that time on the lesson. So again, that's how we come about to this. Okay. So we're going to do some practicing on the back, and this is probably something that we are not going to finish today. It's probably going to take a couple days, but we're going to have you guys do some practicing. All right. So we are going to do, if you turn the page, it should look like this, and we're going to start with the top two boxes. So the first box is we're trying to find the length of the first side. Well, if you notice, the length of the first side here is a straight line. So which means we can make a little box here. And we know that this little box all the way around, each length is 1 unit, right? So that means the side length that we are looking for, the answer is 1. The length is 1 unit. Okay? And again, those are what we call perfect squares because the square is perfect. Okay? And you have to give me 1 second here. I have to pause. All right. Sorry about that. So I'm back. So we're going to do the second one together. And I'm going to try to turn you loose for a couple. All right. So the next one will be the top right. Now, we have a slanted line here, right? It's a diagonal. We can't make a perfect square like we did in the first box. So we are going to make a right triangle. Whether we draw it here or you draw it there. Okay? Either way, the sides of the two legs are 1. Okay? So our little workout to the side here, we got 1 squared plus 1 squared is going to equal our other side squared. Well, 1 squared is 1, plus 1 squared is also 1. And that equals our side squared. So what's 1 plus 1? Right, 2. And again, to get s squared to s, I must square root both sides. When I square root both sides, the square root of s squared is s. And then I can leave my answer as either the square root of 2, okay, because that's a more exact answer than when I take the decimal form and round it, right? The square root of 2 is a value, okay? So, you know, that's pretty easy. Or, using my calculator, I can go find the square root of 2 to be a decimal, and that is, as I'm putting it in here, we'll say about 1.4. So that is our value of our length for the second box. Okay, about 1.4. So here's what I want you to do for the next part of the video. I want you to pause, and I want you to work on these two boxes, here and here. And I want you to find me the side lengths for those. So we're going to pause the video, and I'm going to let you work for about 5-10 minutes, or sooner until everyone's done. And then we'll go over these two. So work on the next two. You're trying to find the side length of the two lines that are drawn there. All right, go. All right. So we're going to see how you did. So to find the length of the box on the left, it's 2 units long, right? So we could make a 2 by 2 square, which means everything around this is one of those perfect squares, right? So the length of the side we were looking for was 2 units. And again, since we're dealing with just a straight length and not area, it's not squared or cubed, or it's just units. Okay. But now the next one, you notice we have a diagonal, which is not a perfect square. So again, we can draw a right triangle. And again, you could have went this way, or you could have went this way. And if you notice, it's the same dimensions as our practice one on the front. So again, to figure out this side, right, it's 1 squared plus 2 squared equals your side squared. So 1 squared is 1, 2 squared is 4, 1 plus 4 is 5, and again we square root to get it to s. So you get your answer is the square root of 5, or what do you say the square root of 5 was on the front hand side? What was it? 2.2, right. So again, this would be our length for that box. Okay, so let's move it down. Let's continue to work a little bit more. So we got two more parts on the bottom. So why don't you, again, take a minute to pause this video, and you and your shoulder partner can try to make it work. So take a second and see what you can do here, and we will take a look at it when you unpause the video. All right. So in the right triangle here, we got a diagonal. Okay. So I can make a right triangle. All right. So again, trying to find this length. So I got a 2 and a 2 are my two legs, 2 by 2. So again, I'm trying to find the length. I have 2 squared plus 2 squared equals my missing side squared. Well, 2 squared is 4. 2 squared is 4. 4 plus 4 is 8. And again, to get side squared to just side, I'm square rooting both sides. So for the side, I get the square root of 8, or the square root of 8, which we did the other day, was about 2.8. So again, that side that we were looking for was 8. Okay, so let's try our long side now. Here we got a flat side, which means this should be a perfect square, right? This has a side length of 3, right? If we start here, 1, 2, 3. So we're going to draw a 3 by 3 perfect square. And if it's 3 all the way around, our length is 3. The area of this thing is 9, but our length is 3 units. All right, because this happens to be a perfect square. All right, very good. All right, so we're going to move on now to the last page. We have 4 more to draw. Okay, if you look on your last page, there's 2 blank ones down here. We're just going to put X's through that. Okay, not going to do that. So let's go ahead and pause the video now. You got two different triangles right here that you're going to try to figure out those side lengths of those 2 diagonals. So go ahead and we're going to pause the video again and see what you come up with. These are a little tougher, so you may take a little bit longer to do. So again, when you unpause this video, we will unveil the answer. All right, go ahead and pause it. All right, so the first box here, we make this a right triangle, which means there's a leg and there's a leg. So this is the side we're looking for. The short side is 1, and the long side is 1, 2, 3. So again, I'm going to have 1 squared plus 3 squared equals our missing side squared. All right, so we got 1 squared. 1 squared is 1, and 3 squared is 9. So 1 plus 9 is 10. And to get the single side, so we can find our actual length, we're going to square root both sides, and I get the square root of 10. Or, again, you can get an approximate answer. If I take the square root of 10, about 3.16, we can say 3.2 would be our approximate answer. And again, that is our missing side. That's the length of that side. Okay. Now, if we go to the other one, looks like it's a little bit longer. Because again, when I make my right triangle, one side length is 2, the other one is 3. So again, I'm trying to find my missing side. So I got 2 squared plus 3 squared equals our missing side squared. All right, so again, 2 squared is 4, 3 squared is 9, and 4 plus 9 is 13. So again, when I try to get it down to just the side length, okay, I square root both sides again, and my answer becomes the square root of 13. Or if I want to find the decimal value, I punch it into my calculator, and I get 3.605, so about 3.6. And that would be my side length for that one. All right. So for the last two boxes, well, the one we got is a perfect square, right? So if you notice, this is 4 units long. So we're going to make a 4 by 4 square. Okay. So obviously the side length for this one is 4 units, right? Okay. So with the side length here being 4 units, I'm going to give you an opportunity to do the last one here with your shoulder partner. So we're going to go ahead again for the last time and pause this video and draw our last shape. So again, take a second, pause the video, and see what you can find for our last side length. All right. So if I draw my right triangle, I'm on a little delay here. It's a little weird. This is a 1 by 4, my 2 legs. So again, here's my missing side we're trying to figure out. So we're going to have 1 squared, the short side plus the long side equals the missing side, all squared. 1 squared is 1, 4 squared is 16. When I add 1 and 16, I get 17. And again, to get the side by itself, I square root both sides. So I'll get the square root of 17. Or, if you take the square root of 17, you should know it's a little bit above 4, because the square root of 16 is 4. So it's 4.123. So we're going to say 4.1. And that would be our side length for our last one. So again, when we're trying to find the missing side length of any kind of diagonal line, we can draw a right triangle and square those two sides to find the side length of the diagonal by taking the square root of it. And that was kind of the whole point of our little lesson here, which will lead into the Pythagorean theorem. So the homework part for this section is page 30, 38 and 39, and then page 32, problem number 44. So again, we hope you found this video helpful, and we are going to sign off.